I'm going to talk about some work we've been doing applying a simplified portion of our Novamente cognition engine AI system to the problem of controlling virtual agents in virtual worlds. And we've taken a somewhat different approach from the previous talk, in that rather than trying to kind of code rules and using a logic engine to govern high-level functions, we're using initially more of a learning approach and working with virtual animals, doing more basic tasks to do with perception, action, and social interaction. I'm going to go through the first 3 or 4 minutes of my 10 minutes, telling a little bit about the Novamente AI approach, for those who may not be familiar with it, talk a bit about what we're doing with virtual pets. Then for the last couple minutes, we'll show a video of virtual pets in Second Life. The Novamente cognition engine, most of you are probably at least slightly familiar with it, and in 3 minutes I'm not going to enlighten you too much further probably, but it is an approach to artificial general intelligence which has a pretty large and well fleshed out design spec and architecture, which I believe is capable of being taken all the way to human level AGI. I'm certainly not going to try to justify that in the first 3 minutes of this talk, but I'm merely going to overview some of the key aspects of the architecture. In terms of knowledge representation, we use nodes and links, a weighted labeled hypergraph, which combines aspects of probabilistic semantic networks with some aspects of attractor neural networks with kind of Hebbian learning in there. So it's an evolving graph with nodes and links. Some of the nodes and links may represent very low-level specific things like perceptions of something in the world or actions carried out with a certain joint on a real or virtual robot. Some of them are abstract concepts, some of them are just nodes that have no English language correlate. They're just formed by the system as combinations of other things in its mind. We have a container called the atom space or atom table containing a bunch of nodes and links, a number of cognitive agents that act on it, carrying out various more or less intelligent processes. It's a networked architecture, so we have a whole bunch of these atom tables with different mind agents working on them, running a bunch of different machines. In terms of the learning algorithms that live in these little mind agent boxes, that's really the deepest part. We have a probabilistic logic system called PLN, which Matt Eclay talked about one aspect of earlier today in terms of how it deals with quantifiers. An automated program learning system called Moses, which was developed primarily by Moshe Looks, who's in the audience here, although he's not giving a talk this year. And a mechanism using artificial economics to allocate attention among different nodes and links and different mind agents in the system. And the idea is that all these things are supposed to work together, kind of alleviating each other's combinatorial explosions, allowing the system to carry out complex goals in complex environments in a scalable way. The cognitive architecture ultimately is not that different from the architecture underlying Stan Franklin's LIDA system or Nick Casamatis' poly scheme. It's based on modern ideas in cognitive science, and the teaching methodology that we're using at the present time is primarily based on social embodied interactive learning, and we're now focusing on virtual worlds for many of the same reasons that Sibley outlined and that were discussed in the previous talk. I don't want to dwell on this, but this you can't even see the lines very well here. But this is an architecture diagram somewhat similar to the LIDA diagram that was shown before, where we have perception coming in from a simulation environment, nodes and links and mind agents concerned with sensory processing, then go into an active memory, which actually combines short-term and long-term memory dynamically in a certain way. There's long-term storage on disk, and you generally have a dynamic where perceptions come in, go into memory, they get thought about, they generate actions, do things in the world, and you keep looping around. And the Novamente cognition engine, which I've been talking about, is a pretty detailed and fleshed out design within this general approach. As I've mentioned, we're also working on an open source project called OpenCog, which uses Novamente's knowledge representation and overall software framework, but doesn't make strict commitments about the learning algorithms. In OpenCog, you can plug in any different learning algorithms to our knowledge representation and architecture and see what happens. That should be launched later this year. Now, why do I think this might work? I mean, of course, you never know until you're there, right? We don't have a human-level thinking machine yet. It could all fail for some reason that I'm not seeing yet. But I put a decade of work into the sort of mathematical, conceptual theory of mind underlying the Novamente system. And for the last 7 years since Novamente was founded, I've been working with a team of great software engineers. I'm working on a really scalable, robust software framework underlying the thing. So it's certainly has been well thought through, and there aren't obvious mistakes there. And we'll see how it unfolds as we experiment over the coming years. Leading into the work on virtual pets, I like to think about our work on Novamente as in terms of Piagets stages of cognitive development. You start out in an infantile stage where the system's just kind of fiddling around with sensation and actuation in the world. Go on through more and more abstract stages, a concrete operational stage. There's a richer variety of learned mental representations and operations. Finally, formal abstraction, where the system can control its logical operations in a way that's guided by its own experience and is effective at learning complex things. And ultimately, you get to a stage where the system can understand and control all its own structures and dynamics and self-modify in a way that human beings are not fully able to, because we lack that full introspection and control over our own mind states. And a more fanciful way of looking at the Piagetian hierarchy is you can start out at a very low level, either with babies or with animals that don't have a deep formal understanding of things. And you can progress up from simple animals that understand language, virtual babies, virtual adults, and of course that's not the limit. We can go on even beyond the human level, and beyond that to some sort of intelligence that's even incomprehensible to us altogether. Now, getting to the practical part of the talk, where we use a sort of subset of this overall architecture to control virtual pets and virtual worlds. One of the papers that I think is going to be seen as one of the more important ones in the history of AGI when we look back is by John Laird, who we actually have here. And the paper is Human Level AI's Killer Application, Interactive Computer Games. And this was in 2000, and I think that's it's going to prove prescient. I think it's not really come to life yet, but with the growth rate of games and online virtual worlds, I really think this is the domain where AI and AGI are going to first really flourish in a powerful way. And in that same theme, if you look at animal level AI as opposed to human level AI, it seems to me that virtual pets, rather than IBOs, for example, are the place where we can have the biggest impact the most quickly for many of the reasons that Sibley outlined. Just a quick overview of the universe of virtual pets. I mean, there's virtual worlds are just running rampant. About a quarter of the 34 million kids and teens on the web in the US now are visiting virtual worlds, and it's growing really fast. And there's more and more virtual worlds coming out on mobile phones and the internet. You have almost 500,000 people joining virtual worlds now. And there's just virtual pets all over the place, mostly aimed at children. Your Neopets, GoPets, Club Penguin. QQ Pets in China has 55 million users. And pets, video games, if anyone has children, you've probably seen these on your TV screen or Nintendo DS or whatever. The pets and mobile phones, Nokia has them, Docomo is launching them. So there's World of Warcraft is filled with pets. But what's the problem with these pets is that they're pretty much all morons. I mean, Nintendogs, which my daughter loves, they have 26 tricks, and that's all they can do. Once you tell them all 26 tricks, that's it. They can't learn anything else. So they're rigidly programmed. They don't respond emotionally in a flexible way. They lack individual personality, and they lack the ability to genuinely learn. What's called learning in the virtual pets is just kind of unlearning the stupidity that's wired into them. How can you build a better pet brain? You want to let the pets genuinely learn, respond to the environment, so that users and pets can bond with them more thoroughly. That's what we've been looking at with building the Novamente pet brain, making pets that respond to and interact with objects, creatures, and avatars. So if you have a virtual dog in a virtual world, if a cat comes by, it'll react to it. It may chase it. If you try to teach it that when you throw a stick, it should fetch it and bring it back, the dog can learn that, and it can then learn to go fetch attractive women and bring them back, even if that was never taught to it in advance, just because you taught it by example and by reinforcement. So I'm going to show in about a minute video of a virtual dog in Second Life being taught to fetch and do simple tricks of playing soccer and so forth by the user shows something, the pet tries to copy it, and you reinforce it. So we're looking at three kinds of learning here. Imitative learning, where the teacher acts out a behavior, showing the student, in this case a dog, by example. Reinforcement learning, where that's more like how dogs are normally trained, using clicker training and so forth. The dog does something and you reward it. Generally positive reinforcement works better than negative, but you can give both. Then what I call corrective learning, where like if you want to get your dog to sit, you just push its butt down the ground, and then it will learn that that's what it's supposed to do because you're guiding it. And the combination of these three kinds of learning seems to be actually quite powerful. So you can also teach with a partner, which is an imitation of a kind of teaching that's used to teach parrots things, where the partner acts out a behavior, then the dog tries to copy what the partner was doing. The architecture we use for this is a simplified version of the big Novamente architecture diagram we saw before, where you have a component that controls the pets, and each pet gets its own little object in here. We have a store of the collective memory of all the pets, so each pet can to some extent benefit from what was taught to the other ones, which is kind of cool. Then we have learning servers, which use Moses hill climbing and learning algorithms to learn new behaviors based on experience. And the next generation of the pet architecture, which we're now working on, integrates more fun stuff like the probabilistic logic engine that Matt's been working on, some natural language processing to help the pets more fully understand commands expressed in more complex English. And the next step, which I don't have time to talk about, is going beyond virtual pets with sensory motor behaviors to pets that exercise simple linguistic ability. I really think this is where it's at. Let's look at the movie now. Once you get to the point where you have virtual agents in virtual worlds and you're teaching them language and they're learning to communicate with you better and better, I think that's where we're going to see an incredible exponential increase in the intelligence of our virtually embodied AGI system. So what we're going to see here is another Second Life movie of our prototype system and what it can do with a virtual dog. This guy is human controlled, and this demonstrates the AI behaviors. So what you're doing here is he's showing you how to sit, and the dog's like, what the hell are you doing? Huh? Currently, the dog doesn't actually hear the sound, it just responds to the textual commands. Huh? Okay, now fetching, I believe in this example, is something it already knows how to do. Well, let's see. Oh, I see. He's going to teach it to fetch with the two-teacher method, so that what he's going to do is have his girlfriend play fetch for him, and then the dog is supposed to basically play the role of the girlfriend and learn to fetch like the dog did. So that's imitative learning. Then it'll be reinforced in how well it did.
You're not very hard.
Yeah. So like I said, right now the language processing is very simple. It can only handle some basic template phrases, but we have a fairly complex language engine that will integrate with this later this year. The animation needs some work, as you can see, but this is an early stage prototype. So. All right, that's a very simple demonstration. There's actually a lot more we can do than that, but I hope that just kind of hints at the ability for kind of sensory, motor, social, integrated learning you can have in the virtual world environment.